Saving the best for last. Well, thank you all for being here today, and thanks to LASCON for having me out. So today I want to talk about some work that we've done and some things I've observed doing threat modeling for IoT systems. One of the nice things about being a CTO is that no one knows what your job description is. So you have broad latitude to do whatever it is you feel like doing, as long as you occasionally show up at events like this and give talks. So what that means is I get to play around with things that I find to be really interesting. And looking at a lot of the work that we've done over the past couple years in IoT security, that was an area where I had the opportunity to play around with that, largely because of my role as CTO, as that we then transitioned to more commercial work. But it's really interesting to see all the incredible stuff that you can do these days with IoT systems. And I've got a great example of that here in just a minute. Again, just a little bit about my background. Again, founder and CTO of Denim Group. I'm a software developer by background. Some early server-side Java stuff in the mid to late 90s, some early ASP.NET stuff in the early 2000s, but really have spent the last 15 or so years working with organizations to help them deal with the security associated with the software systems that they're building and deploying. And so I'm a software developer that has come into the world of security as opposed to someone with a more traditional network pen testing background that's now looking at web or mobile or IoT apps. I help run the OWASP San Antonio chapter, and my dog ate that coat not too long ago. He's a good boy, sometimes. So I'll start with a funny story that I suppose is tangentially related to security. I got a call from one of my business partners a couple days before Christmas last year, and as it turns out, he had been watching his neighbor's house. They were out of town, and they were getting a bunch of packages delivered, and he noticed someone over there messing around with the packages. And so he went out in his pajamas and walked across the street and walked up to a guy messing around with the packages on his neighbor's porch and said, "Hey, can I help you?" And the guy turned around with a ski mask on and a knife, right? Like you had called central casting and said, "I need you to send a burglar." And they said, we've got just the guy." And when he pulled the ski mask down, he had tattoos on his face. So central casting really outdid themselves this time. So my buddy said, or my business partner said, "Never mind, we're gonna take a couple steps back." Called the police. This guy wandered off, and the police showed up, and he got to talk to the police, and they're like, "First of all, that was pretty stupid what you did. As a father of 2 young children, that's probably not something you need to be doing. We'll look through around the neighborhood and see if we can find him." And what my business partner figured out later, he'd called the neighbors and let them know that this had happened, and had been gathering the stuff up, and they're like, "Oh, we've got our doorbell camera probably caught it all on tape." And so they sent him the video footage of him confronting this burglar. What an amazing world where your children one day can watch you get stabbed for asking simple questions. So IoT, that was great work. So what I want to talk about today is an overview of IoT, or at least my perspective of IoT and what I mean when I'm talking about different corners or different aspects of the IoT world. I want to talk then about the goals of threat modeling. Why is threat modeling an activity that is valuable and that organizations might want to use? And then look specifically, why is threat modeling a technique that is of particular value looking at IoT-based systems? I'll provide a very quick overview of an approach to threat modeling. We don't really have time to get too deep into that, but I do have links to some external training materials that we've made available in that area. And then I'll look through some interesting corner cases, some interesting aspects of threat modeling for IoT systems. And then at the end, we'll have hopefully some time for questions. If you have a question along the way, please feel free to raise your hand. They've got lights shining on me, so you may have to wave your hand around a little bit to get my attention. But please feel free, if you've got questions along the way, to let me know. So an IoT overview. IoT is cool. Again, that's a fun aspect of my job, as I can direct research where I think is interesting right now that hopefully is more commercially relevant later. And as we saw from the description before, like Nest, Ring, Fitbit, Amazon Alexa, right? There's all kinds of really cool stuff that you can do with these internet-connected devices that are collecting data, that have GPS on them, that have cameras on them, that have audio, picking up audio and things of that nature. So really, really cool stuff. One of the first things that I learned as I started looking into IoT systems is that apparently you're only allowed to use 3 colors if you're an IoT company. You're only allowed to use 3 colors in your logo. Little known fact. And when you look at IoT, or when the press talks about IoT security, the focus is really almost always on consumer IoT. And so looking at these wearable devices, breaches of information. Hey, look, Strava is letting people know, when folks in the military are going on runs in foreign countries and things of that nature. And so there's a real strong consumer focus in the press when they cover IoT. That's all well and good, but IoT isn't just consumer IoT, and I would argue that if you look at, in terms of impact to the world from an economic standpoint, and certainly from a security standpoint, industrial IoT and enterprise IoT are far more, or have a far greater impact on the world. So what we see are a lot of enterprises that are adopting consumer IoT, but putting them into their enterprise infrastructure, and that creates all sorts of opportunities for these enterprises, otherwise they wouldn't be doing it. But it also comes with it a number of risks and a number of challenges, because they're taking, again, these consumer devices and trying to put them into an enterprise context from an information security standpoint. Also looking at the industrial use of IoT, they're adopting whole other IoT solutions for themselves, looking at smart light bulbs, factory control and things of that nature. And so a whole other part of the IoT space. And so I think it's really important to not just think of IoT from the standpoint of doorbells, cameras, wearables, and this consumer-focused stuff, but also to understand the impact on enterprises and the impact on industrial organizations as they adopt this stuff as well. So here are 3 definitions that I made up, and you're free to disagree with me if you have different thoughts. Again, love to hear that. But when I talk about consumer IoT, what I mean are IoT systems that are sold to the general public. Front door cameras, exercise trackers, personal assistants, and things of that nature. When I talk about enterprise IoT today, what I'm talking about are enterprise organizations that are deploying IoT systems in support of their stakeholders. And the most common use case that we see are consumer-oriented devices that are being deployed into enterprise environments and into enterprise IT infrastructures. When I talk about industrial IoT, what I'm talking about are typically these more specialized IoT systems that are sold into industrial environments. So smart lighting, connected control system, industrial equipment enhancements, and so on and so forth. And so for the purposes of this talk and just in general the way that I think about the space, this is how I look at the differences between how consumers, enterprises, and industrial organizations are adopting IoT. So why are these different groups concerned about security? As a consumer, you're asking, I'm using an IoT device, is this safe? For enterprise and industry, they're saying, I'm deploying IoT devices into my environment, what are the risks? For developers, the enlightened ones, at least, or the more enlightened ones, say, hey, I'm building an IoT system, what should I worry about from a security standpoint? So I want to talk a little bit about my bias in looking at IoT and IoT security. So my view of the topic is skewed by my experience, and that is predominantly acting as a consulting firm, helping organizations deal with the risks associated with IoT. So consumers don't pay us because they're too poor. Right? Is anybody out there buying like a $60 Alexa assistant? They might want to pay for a 5-figure threat model for that system. If you do, please come and see me afterward. we would. No one loves your money more than me and my organization. We would love to talk to you, right? But if you look for consumers, when they're looking at IoT and having questions about security, they are largely getting what they get. But people that sell to consumers occasionally do work with us to protect their brands and their systems. They're saying, hey, trust is an important part of our brand. Like we want to make sure, we want to decrease the risk of breaches or problems associated with our products. Enterprises we work with to help them be safer when deploying IoT into their IoT infrastructure. Industrial organizations similarly help us or work with us so that we can help them to be safer when they deploy IoT systems into their environments. And again, different IoT system builders, we work with them to help them build safer and more secure IoT systems. So again, from a consumer standpoint, sophisticated consumers might informally threat model IoT systems, the IoT systems that they let into their lives. I've had a conversation with my wife where she's like, hey, should we get an Amazon Alexa? And I'm like, do you really want something listening to all the stuff we talk about here? She's like, maybe that's, maybe that's not, right? Maybe that's, that trade-off isn't worth it to us at the current time. But really, consumers are just going to kind of get what they get, and they rely on brand in order to make decisions. And so, so again, that's something you can make a decision to say, hey, I think that Jeff Bezos is a pretty solid stand-up guy. Maybe I'll put one of his microphones in my house. Yeah, but that Zuckerberg dude, no, like those guys are crazy. We're not gonna trust anything that they might decide to put out, whatever that might be. But again, for consumers, they're on the receiving end of whatever they get. For enterprise and industry, this is really a supply chain concern. I don't see a lot of enterprises building their own custom, internal-facing IoT stuff, right? They're typically buying this from others. Same thing with industry in most cases. Whereas enterprises and industry will build software systems, line of business web applications and things that they'll consume themselves. Most organizations that we work with, IoT security starts primarily as a supply chain concern because they have questions of, this vendor is doing stuff, they're building devices, those devices talk to services, we're putting them in our environment. What is the impact going to be? But they don't have as much of an ability to directly influence the security impact because they have to they have to influence their vendors in order to do what they want. But where enterprise and industry use threat model is to identify potential risks that come up in the acquisition process. To understand, what are the capabilities of this device or devices we're putting in our environment? What information are they collecting? Where are they sending that information? How is that information going to be processed? Based on that, then these enterprises and industrial organizations can make a determination to say, this has an acceptable impact on our security posture, or it has an unacceptable impact on our security posture. We are or are not going to move forward with an acquisition. Assessments of IoT systems can also be used during the acquisition process in order to make determinations. From a threat model standpoint, here's architecturally how this fits. We're going to assess the device and the services. Now we see if there are an actual vulnerabilities that impact the security. Again, make that go or no-go decision. And notice I'm talking here about the acquisition process, not the deployment process or even later. That's something where as a potential customer, in a lot of ways, you have more power as a consumer before you have signed a contract. Before you're a customer, you, in a lot of cases, have more leverage than if you are a customer. And that's something that we've seen before, where we have, we've had assessments queued up before by banks, for example, looking at mobile apps, post-purchase of mobile app or post-licensing, and say, okay, cool, well now these guys are going to go in and do testing of this system. And the vendor says, no, they're not. Like, we didn't authorize you to do that. And they're like, right, we're a customer, and we really want to know about security. And they're like, well, you should have thought of that during the contracting process, because now we're not going to authorize you to do this. We're not going to authorize you to do that type of testing. Is that an enlightened view? No. Are other bad actors probably going to provide free pen testing without the report? Probably, right? But again, that's a challenge that you have as a consumer of these systems, or if you're looking at your supply chain, is you need to realize when you have leverage and use the leverage at that point. So when we look at developers' threat modeling for IoT systems, developers can use threat models to avoid introducing huge issues that are expensive to fix and are embarrassing to have publicly revealed. These threat models can help identify problems with authentication, problems with authorization, structural problems with these IoT systems, hopefully during the development process when those things are easy to fix. The most expensive vulnerabilities that we've found in my career doing security testing, our work doing security testing, find all sorts of vulnerabilities. The most expensive vulnerabilities to fix have always been ones that would have been very easy to have found early during the design process with a whiteboard-based threat model. And so it's attractive in a lot of cases to do that whiteboard-based threat modeling as opposed to paying 7 figures later on to try and fix some sort of connected system authorization bug. For developers, again, certain development teams that we work with, or certain organizations where we work with the development teams, view security and privacy as a differentiator. And so they want to make sure up front to make that a priority that they can communicate about with their customers. Other organizations simply don't care. So let's talk about the goals of threat modeling. Why would you want a threat model? First reason, and I talked a little bit about this, is avoid introducing vulnerabilities. Second is identify vulnerabilities in an existing system. And one of the things we've found in working with a number of organizations is there's also a tremendous value that isn't often considered of understanding the system and the security characteristics of the system that you have built so that that can be communicated among developers and other internal stakeholders. I'll talk a little bit more about that. So first, avoid introducing vulnerabilities. It's far cheaper to identify potential problems on the whiteboard than it is to fix them at the keyboard. And it is certainly easier and cheaper to do that up front than it is once you have some large number of devices deployed out in the wild that are talking back and forth and doing things. And so threat modeling is a great way to proactively identify potential issues during the design process so that you can alter the design, you can alter the architecture, you can pay attention when you're coding and when you're deploying. And avoid introducing these vulnerabilities and risks into operational systems. Threat modeling is also a great way to find existing vulnerabilities. As I'll show, threat modeling is a structured way of looking at a system, of chunking out and here are all the different pieces, here's how they're communicating with one another, and here is a repeatable way that I can take this structured view of the system and turn it into a checklist of things to be concerned about. And one of the real values that we've seen to threat modeling is it can provide a level of consistency to assessments and penetration tests. There's always going to be a little bit of magic and art in pen testing, as the panel before was talking about, I'm sure, as other talks we've heard. But if you want to add a level of repeatability, we found that threat modeling is a very good structured way to do this. Here are all the parts of the system, here's how they communicate. As we'll show you, here's how you identify the risks, a checklist of things to look at. As you work your way through that checklist, a competent person is going to get to a similar place versus another competent person versus just letting folks loose on a system, willy-nilly trying to find stuff. So threat modeling we found is a very good way to structure assessments and testing to add, to ensure a level of completeness as well as to enforce consistency across assessments. Another thing that we found to be very valuable about threat modeling is it helps development teams understand the security characteristics of the systems that they're building. And so more than just identifying, hey, here are the potential problems with our design right now, but really to understand, here are the types of problems that can be introduced. And as we change this system over time, here are the types of things that we need to pay attention to, right? What are the parts? How do they fit together? If I change this, what's happened to that? And it really can encourage great critical thinking. And that's one of the things where if you look at the results of testing, you've got an assessment report PDF document shows point in time, here are the security characteristics of the system as it exists in time. What we've found is that a threat model tends to be a much more durable document, right, or a durable thing to produce because the architecture and design of your system is going to drift more slowly than the code will, and it's the type of thing that you can work with developers to bring new folks up to speed and again to start that conversation of how do these different pieces fit together, what are the security characteristics of the system. And so threat modeling is something that we found to be a very valuable practice for development teams for these reasons. So why would we want to threat model IoT systems? So the good old days, right, this is a nice web application threat model. You've got the user on the other side of your trust boundary. Then you've got your web and application server. All your code is running here. And that is probably talking to a relational database, right? The good old days. Threat modeling for a web system, done. Obviously, more complicated systems, in a web environment, more complicated systems can have more complicated threat models, but at a sketch level view, this is you can lay this out and you're going to be right in a lot of cases for more traditional line of business web applications. And so this is great because it gives you the ability to have communications with developers, and you can provide standard advice that is good advice and works in 90% of the situations, right? So you can say, look, here's your application, and the users are on the other side of a trust boundary, right? You show them a little demo with WebScarab or with Zap to show like, oh, here's how I can change cookies, here's how JavaScript can't properly validate stuff, and you can show the developer like, hey, be afraid of anything coming across this trust boundary, you got to validate it, you got to treat it as like it might be hostile. Okay, good. That's a lesson. That's a very straightforward lesson learned, and is straightforward, hopefully, to apply. Same thing with the database. Then if we look at the evolution of systems, then we get into a mobile environment. Well, now our old threat model is now like basically all the way over here on the right side, right? These enterprise web services in a mobile application threat model tends to, that's, again, you've got users on the outside that are scary, you've got your stuff on the inside that's fine, great. But now we also have a bunch of code that's running on a mobile device that we don't control, right? That might have other programs running on it that are malicious. You might have a malicious user, and you might have third-party users that say, I'm not going to use your mobile client, I'm just going to attack your web services directly. Oh, and you may be talking to third-party web services, who knows what those folks are doing with the data, right? So as you move from web to mobile, the threat model gets significantly more complex. But again, still, you can start to use this to craft some lessons for developers that are hopefully durable and work 75% of the time. Then you get into an IoT environment, and all of a sudden the architecture, the possible architectures really go sideways on way, because you've got these IoT support services, kind of like the enterprise web services. Maybe you have a web client, there's bad guys talking to the web client. Maybe you got a mobile client, bad guys talking to the services there. You've got your IoT device talking to third-party services. Maybe there's bad people using the IoT device. IoT device might go through a local IoT gateway. Right? We're starting this proliferation of pieces and parts that are all communicating in ways that you didn't necessarily think of, and that vary greatly between different different implementations. And so the reason that, or where I really realized this, or where this kind of came home for me, was a couple years ago, we had looked at all of the mobile assessments that we did and ran some statistics across those. I made that basic threat model that we saw before. You've got code in the mobile device, you've got code in third-party services, code in enterprise services, and we basically went through and said, for each vulnerability that we identified, what was the severity, what was the type, which part of that threat model did we find it in, and how did we find it? Static analysis or dynamic analysis, manual testing, or with automation. And that let us run some stats that I at least found to be interesting and very helpful, so that you could look to see where do we find the worst vulnerabilities? Where do we find the scariest stuff in mobile systems? Is it on the mobile client, or is it in the enterprise web services? Hint, it's the services in a lot of cases. And we can also look and see, well, what are the prevalence of these types of vulnerabilities, and how does that stack up against the OWASP mobile top 10? Similarly, we can look and say, hey, if you're looking at rolling out a mobile security program, do you want to focus on static? Do you want to focus on dynamic? Given limited resources, where do you want to deploy different technologies and resources in order to get the most impact? Turned out to be, again, I found it to be really valuable research. I think a lot of organizations got some benefit out of it. Since I'm not terribly creative, as we started doing a bunch of IoT testing, I thought to myself, like, remember we did that stuff with mobile and it was kind of cool and people got some value out of it? Neat, I'm going to do the same thing for IoT systems. So I chunked together a real basic threat model similar to the one that we had before, started chewing through reports and saying, okay, well, this vulnerability goes here, this vulnerability goes here, so on and so forth. Got through a couple reports and found one that I couldn't really find a place for. So I went to the guy that runs our AppSec testing program and I said, hey, like, here's my threat model, where did this vulnerability occur? And he said, well, that vulnerability only exists because they took that consumer IoT device and tried to stuff it into an enterprise authorization infrastructure. I said, well, I don't have a box for that. He said, I don't care what boxes you have, like that's what that problem was, that's where it comes about. Add a box to your threat model. So I did that and went back and chewed through a couple more reports and found something else, went to the guy and said, hey, like I found this other thing and this doesn't exist, like this, I also don't have a box for this. And it was in a wearable device that we looked at that communicates out in some weird ways. And he said, oh, well, that vulnerability only exists because this particular system does this and this and this. I said, I don't have a box for that. He said, again, like make more boxes or do whatever you want to do, but like I've got work to do. Quit bothering me with this stuff with your crappy threat model. And so the problem was that the problem was that these IoT systems had wildly varying architectures. Whereas again, in a web environment, you can start with a base and you'll be 90% right. In a mobile environment, start with the base and you're 75% right. In IoT, I was 50% or less. When I started really looking at a lot of this stuff coming out, because there certainly were some commonalities or some patterns that existed, but nothing close to what I'd been able to boil down before to say, here is a stable, here's a threat model that is X% correct. Use this as a starting point. So where does that leave us? When I looked at that, again, the realization was that IoT environments are complicated and varied, and they're potentially significantly more than a lot of systems that we'd looked at in the past. And there's a kind of a double-edged sword there. It was frustrating not to have a template threat model that got us most of the way done, but I also saw threat modeling as being even that much more valuable in these IoT environments. Because from a security standpoint, if I want to be able to talk to developers and I want to be able to give them actionable advice for things that they should do, right? If I can't, if it takes me time to understand the system and to figure out how the pieces fit together, think of how the developers, who are probably very task focused, they're in an even worse situation. And so threat modeling for IoT systems, I view as being a tremendously important practice, such that I don't know how you would be building an IoT system that you would make any sort of security assertions about in the absence of having at least some level of threat model so that you could communicate from a security architecture standpoint how all the different pieces fit together. So I want to go through just a very quick overview of threat modeling. We don't really have time to get super deep in the weeds on this, and I've got links at the end, again, to some training materials that we've published to talk about this. I usually look at threat modeling very similar to the Microsoft style. And so from a threat modeling standpoint, we want to decide on the scope of what we want to include in our threat model and what we don't want to include, what's in, what's out. We're going to go and look at the system and build our data flow diagram. From that, we're then going to enumerate threats. Then we make decisions on mitigations. So fairly straightforward. So we create data flow diagrams. Jordan DeMarco style data flow diagrams are what we like to use. I remember when I was coming up through college, in our software design classes, the professor had us use Jordan DeMarco style data flow diagrams. Since I knew everything back then, I was like, this is crap. Nobody uses this stuff in industry anymore. It's all UML. And apparently my professor gets the last laugh, because fast forward 15, 20 years, and now we're back to using Jordan DeMarco style data flow diagrams. But basically we want to decompose the system into its assets. What are the external interactors? What are the processes internal to our system? And you can look at those in varying levels of granularity. Where are we storing data? How do all those pieces talk to one another? And from that, then we can draw trust boundaries. And so what does that look like? Again, here we've got a web application. It's talking to some sort of external third-party service. It's got a database that it talks to and reads information from. It's maybe writing logs out to something, and then you've got a user out here. Draw your trust boundaries. So again, a somewhat more complicated web application threat model. Nothing too crazy. Then what you can do is, then what you need to do is enumerate the potential weaknesses in the system. And so we like to use STRIDE for this. It's an expansion of the CIA triad, or of confidentiality, integrity, and availability. So looking at where there is the potential to spoof data, to tamper with data, for repudiation of people that participated in a transaction, information disclosure, denial of service, or elevation of privilege. And the handy thing here is that the asset types that we talked about before, external interactor, process, data flow, and data store, you either can or you can't have a certain type of impact on these on those types of assets. And so with this grid, you can look to see, well, hey, for an external interactor, I have to be worried about someone spoofing that external interactor, and I have to worry about repudiation. I have to worry about that external interactor participating in a transaction and saying they didn't, or vice versa. You know, for a process, I'm worried about all of those things: the process spoofing itself, someone tampering with the process, someone repudiating the behavior of a process, you know, getting unauthorized information from a process, turning off or denying service to a process, or elevating privilege, and so on and so forth. And so this, you know, this is the easy part, because you basically take all of your assets, you associate the threat types with each asset based on that grid that we had on the last slide, and voila, now you've got that list of things to worry about. And so when I talked earlier about using threat modeling to provide a level of consistency and repeatability for assessments, that's how that can be done. And hopefully between, you know, again, between two different folks looking at the system, maybe there might be some disagreements in scope about like what's a complex process, what's a process, do we want to break these things out. But we've found that you know, typically folks that have some skill in threat modeling will come to something that looks pretty repeatable across you know, across different threat models. And in using that approach, that gives you a list of things to be concerned about. So if we go back here, you know, then this is going to cause us to ask questions such as, okay, for the web application, how do I know, you know, how do I prevent people from spoofing themselves to the web application? Okay, well why don't we use, you know, a login to do that, right? So we'll talk here about the different countermeasures that you can use. So for each of those problems, potential problems, what are you going to do about it? You can do nothing. That is always an option. And in a lot of cases, it is a totally legitimate option to take. But that's the type of decision that you would rather explicitly make as opposed to making it by default. My favorite anecdote about this, we were working with a financial services organization building a threat model, and they said, we want to ignore the risk of fraud in this case. Right, and so we, you know, we had a big laugh at their expense, but then we thought about it. We're like, these chumps are not worried about fraud. But then we thought about it. We're like, no, these guys actually are doing a pretty good job. Like, they understand their risk better than we do. And with this system, they were doing something really groundbreaking, really industry leading, getting out in front of a whole bunch of folks. And from a business decision standpoint, they had made the determination, like, we will accept a certain amount of fraud. And we've got a whole department, we've got a whole couple floors full of folks that are intended to deal with fraud. We're going to accept more risk of fraud because there's greater value to us and our stakeholders of getting out in front of this, right? We want to be the first with the most, and we're going to accept the risk of fraud to do that. And so, as usually happens when I think I'm exceptionally clever and know more than people, what I actually learned was they were actually very good at assessing risk and value in their environment, and they had made a very sensible decision that let them get out in front of the industry. So doing nothing, always an option. It's better if that's an option that you make explicitly, as opposed to as opposed to stumbling upon it or doing that by accident. You can always remove a feature. You know, that's something, if you're trying to build a threat model and you're like, hey, I really want to do this, but there's no way for me to do this to prevent spoofing, right? So anybody's going to be able to use this feature. I can't control who's going to use the feature. Maybe we'll just remove it. Maybe you would turn off the feature by default. You can also warn the user, with a pop-up. That's always a great option. What could go wrong? You can counter the threat with operations, separation of duties, accountability. Counter the threat with technology. Change the design, change the implementation. So you can, there's no catch-all countermeasure. But again, if we look at this threat model here, again, I might look here and say, okay, to prevent spoofing, I'm going to have a login, right? So this person is going to log in, and they're either going to log in against local database credentials or maybe through an LDAP data store or something like that. I'm concerned about people, information disclosure from these requests and responses. Great, we're going to implement TLS in order to provide integrity and do whatever. In some environments, like an internal environment, you might say, well, we're also going to use certificates with that TLS to communicate identity to prevent these people from spoofing with one another. And so you can basically step through all of the potential risks associated with the system that came out of that plug and crank. and look at each of those and say, okay, hey, we need to, before we build this system, we have to plan for how we're going to manage this certificate infrastructure, because we're using TLS in a lot of places for identity, for confidentiality, and for integrity. Right? We need to make sure, like, are we going to backhaul, do we need to add an LDAP server to this because we're going to be talking to a directory server, or are we going to use a local database where we need to protect these things with salts and other things like that. And so what that lets you do is to create that list of risks and go next to each of those and make a determination. What do I want to do in order to counteract this or address this threat? Or am I going to do nothing for whatever reason that might be? So there's a couple of use cases that we found in looking at threat models for IoT systems. And so there's a couple of, there we go. A couple of things to look for. The initial provisioning and deployment, right? When somebody takes their new device out of the box, right? Or they get ready to set it up. We found a lot of vulnerabilities or weaknesses in systems at that part of the process, and that's something that a lot of teams don't necessarily think about. They think about, okay, well, once this thing's up and running, here's how it's going to protect itself. Here's how we're going to monitor it or whatever. We found a lot of problems with folks when they're doing the initial provisioning and the deployment. We also found a lot of problems with configuration updates, right? If you have a user who has provisioned the device, how do you make sure that the next person who messes with the configuration is someone who is authorized to do that with this device that is out and floating around? As I mentioned, we found a lot of challenges integrating IoT systems, especially consumer IoT systems, into enterprise authentication and authorization infrastructure. So organizations are saying, hey, it'd be really great if we could have these personal assistant devices on executives' desks to do X, Y, Z. Well, but how do I make sure to communicate their identity to the device so other people can't come in and use their device and things of that nature? Similarly, software updates. Once you get the thing up and running, that's great. Over time, there are probably going to be updates, either to address vulnerabilities and weaknesses or to add new features. Have you looked at the security of this update process so that you know the integrity of what is being loaded on the device for iteration N+1 of the software load? In an IoT environment, we also have used threat models to scope assessment work. Again, IoT systems have a lot of different parts. And they have different kinds of parts. So as we looked at before, they've got web applications, web services, a lot of custom hardware. Sometimes they're talking over esoteric protocols, different wireless antennas and things of that nature. And so creating a test plan can be really challenging. You're never going to have all the resources you would want such that you can do exhaustive testing. And so the threat model can help allow you to make decisions about trade-offs. We've got a limited set of resources. Do I want to spend those resources fuzzing the device's Zigbee stack, or do I want to run static analysis on the web server or on the web services? Okay, well, I guess we're going to have to trust, for skill set reasons, for time reasons, whatever it might be. I'm going to trust that the Zigbee stack is not too horribly broken. And more importantly, I'm going to do more testing against these enterprise services that give an attacker potentially leveraged access to data. Right? Is that the right trade-off? Maybe, maybe not. But it's one that most organizations have to make at some point in time. I've got a limited set of resources I can bring to bear on testing this system. Where am I going to get the most value by applying those resources? Safety concerns are also really interesting when you start to look at these IoT devices, because IoT devices have a much greater, because there's a physical device associated with it, they have a much greater ability in a lot of cases to impact the kinetic world. Right, to actually let bad guys reach out and touch someone in a physical way. And if you think about the standard view, confidentiality, integrity, and availability, that's the standard view of in security. There's a lot of focus placed on confidentiality and integrity. And I would argue that the installed base, if you will, of security professionals is hyper focused and over-specialized on looking for or worrying about confidentiality breaches of regulated information, credit card numbers, right? Like that's all the breaches you read about, or the vast majority of the breaches you read about. These idiots did something wrong and lost all of their customer information, right? and I hate to characterize people as idiots, but that's the way that the industry looks at it, right? But everybody's hyper-focused, confidentiality, regulated information, and maybe a little bit of, well, don't let people write to stuff that they shouldn't write to. In an IoT world, and especially as you look at safety, availability starts to potentially be a greater concern, and I would say integrity takes on a greater role as well. And so that's a huge challenge, especially like in an industrial environment, is we're taking these devices that potentially have a kinetic impact, and we're putting them in front of security professionals that don't necessarily have their perspective tuned in the way that is going to be most important if we want to protect aspects of safety. Anybody here a fan of Stephen King? Yes. The Mangler, it's about an piece of industrial laundry equipment that gets possessed by dark magic. All right. Maximum Overdrive, it's radiation from some sort of rogue comet turns all the cars and trucks on Earth into living beings. Right? You know, it used to be that Stephen King wrote the scariest stuff that you would ever see. Now I would argue that the scariest stuff being written right now is probably being written by junior developers writing code that's going to get run on some sort of IoT device, right? Terrifying. Campfire stories just aren't the same. But so that's a huge concern, and so we see that with medical devices especially, where they have a direct impact on human life and well-being. And so when Vice President Cheney had his pacemaker put in, they turned off certain capabilities that allowed it to have remote updates. You know, why would they do that? Because in a lot of cases, it would be super convenient not to have to physically mess with the pacemaker to adjust to make any sort of adjustments or updates. But when you're the vice president, well, there's really only one of you, and there's probably a lot of people that don't like you. And so in that case, you may say, we need to turn off this capability because we cannot properly secure it. And the impact of an exploit, in that it could impact the vice president's life, that the impact of that exploit is so great that we're willing to take off the table the value associated with making this device far more manageable. Again, from a threat model standpoint, looking at the system and making a determination, what works in one case doesn't work in another case. There's some great stuff out there, material from Josh Corman and the We Are the Cavalry folks, looking at safety and security associated with IoT systems. Really good stuff, looking at auto safety, medical device safety. Again, a really strong perspective, and I think that's very valuable in an industry that for a very long time has looked at security in a way that is not optimal. When you go from dealing with financial information and purely information systems and start looking at IoT systems that have a much greater opportunity to have a kinetic impact in folks' lives. I'll point folks at another resource that I've found to be really encouraging. The ARM folks, the processor folks, they have released some threat modeling guides for different specific use cases where they can see their stuff being used. The way that they do threat modeling is a little bit different than the way I've outlined here, but I think this is really encouraging that the folks building the components of these IoT systems are taking security seriously and are seeing security as a differentiator and are proactively providing guidance for the developers building systems to say, here's how you can use what we're providing you in the safest and most secure manner. So, bravo to the ARM people. Very happy to see them do that. I think that's fantastic, and I would love to see more of that across the industry. Where, if you look on a component-to-component basis, those component vendors are not just saying, "Hey, please buy my stuff," but they're saying, "Hey, please buy my stuff, and I want to give you the resources that you need to be successful using this stuff in a safe manner." Also, some additional threat modeling materials if you want to look more deeply into threat modeling and the process associated with that. That's a link on SlideShare to much longer, some training materials that we've put out for threat modeling. Again, we didn't really have time today to go really in depth into the specifics of threat modeling. This provides a really good overview. There's also the book, the Microsoft Press folks had a book from a couple years ago. Really good stuff. There's great materials out there to look more at the mechanics. So finally, just closing thoughts. IoT systems are varied and they're complicated. And increasingly, they're having safety implications where they have the ability to impact people's health and well-being in the physical world. And that's the double-edged sword. That's there's so much value, so many cool new things, valuable new things we can do with IoT. But coming with that is a level of complexity that most folks aren't used to thinking about and aren't used to. Threat modeling we see as being a very valuable technique both to avoid introducing vulnerabilities as you're building systems, as well as to take a structured approach to identifying vulnerabilities in systems that exist. And if your organization is building IoT systems, or if your organization is considering to acquire and deploy significant IoT systems, threat modeling is a technique that can be used, again, hopefully early in the process to increase your comfort with your security posture when you get to the end of that line. Now we've got a couple minutes left to open up if anybody has any questions. And I can't really see you. Anyone? Yeah, there we go.
Is there any kind of a website where consumers can look at relative security ratings for different IoT devices?
Great question. So the question is there a website where consumers can look for ratings of systems? That's a great question. I think the Consumer Reports people have looked into that to some degree. But I don't know if they've published their results in some sort of a registry or something like that. I know that there are some budding certifications. The only reason that I know that there are some budding certifications is because when we came across one, we had done an assessment of an IoT provider's system for one of our enterprises that was looking to deploy it. And when we found vulnerabilities, they said, well, we're XYZ certified to be secure. And I said, I believe you. I believe that you have that certification. However, we need to have a call to go through what we found. And they're like, all right, well, I'm sure you're not going to tell us anything that we're worried about. And we unfortunately ruined the heck out of some folks' day, like late on a Friday. It was like this time on a Friday. And those guys were even Eastern, on the East Coast. So they were even closer to going home, and we ruined their weekend. And I felt pretty bad about it. But since they were, but again, we only learned of that certification that was out there because that organization had gone through it, and as it turns out, it was pretty superficial. Like that's a challenge that we've got, is that it's hard to put things into a bucket to say if you do these 4 things, then you feel like you're secure. But I would first look at the Consumer Reports folks, and I think the Underwriter Laboratory people have started to do possibly some of that as well. I know they've looked at the problem of certifying software systems. I don't know if they've looked at the IoT stuff, but that's a great question. Any other questions?
That was a great presentation. So I know we all came across a recent news where we heard Alexa giving out evil laughs and all those. So when doing a threat model for IoT devices, what are the top few attack vectors that you see? Like those are connected to the internet, being operated by the users and all those. So, but what is the topmost attack vector that you see whenever there's compromise on an IoT?
Mm-hmm. So the top attack vectors that we see, and I'll also remind you that our perspective, we are typically not trying to defend a consumer. We're trying to defend an enterprise that is looking at using this stuff. And so our top attack vector is usually looking at attacks against the services that are supporting these systems. I think from a consumer standpoint, that would probably cause me to look more at the at misuse of the data that the device is sending along. And so from the one side, as an enterprise, I would be concerned about attackers coming in. So I guess it is the same attack vector. It's a question of an attacker coming in through these supporting web services. From an enterprise standpoint, they're concerned about losing the data or the brand associated with that. From a consumer standpoint, the greatest concern that I've seen is the misuse of their data once it is sent up to those services, where the attack vector would likely be those same services that they use to pass the data up in the first place. So I guess it is the same attack vector. It's just a concern about a different concern about the outcome. Any other questions? Can't see anybody. So great. Well, thank you all very much.